Lesson 2, the constant acceleration equations. Or Science 10 done properly, not sloppily. I'm going to start off with a specific example. Here's a graph. Oh, what kind of a graph is this? You want to be with me? You're not looking at your phone or anything foolish like that, right? Put it away. What kind of a graph is this? What's on the y-axis? V. What's on the x-axis? G. I gave you all a lesson, right? You have it in front of you. What kind of a graph is this? V versus T. Okay. We're going to walk through a specific example here. It says, above is a graph showing the uniform acceleration of an object as it was allowed to drop off a cliff. Really? How is it showing acceleration? Where does acceleration appear on a velocity time graph? So part A asks, what's the acceleration of the object? Where does the acceleration appear? Slope. You know what? We got room right here. Let's say A equals slope. You might want to write that down just to jog your memory. And this one, I think, goes through numbers that are nice. I think I'm going to find the slope here and here. Now, we can do this as a graph, or we can actually start to derive this as an equation. We did say acceleration was the change in velocity over the change in time. What's the change in velocity? I told you it was always final minus initial. What's my final velocity? What's my final velocity? 10. Minus, what's my initial velocity? 2. By the way, can you see that rise over run is really change in over change in disguise? Turns out. What about my change in time? What's my final time? 0.8 minus, what's my initial time? I kept it nice and zero, nice and simple. What's my initial time? 0. Okay, what is the acceleration? It's going to be 8 divided by 0.8. Or if you want to practice with your calculator, is that a fraction? Yeah. Is there more than one number on the top? Isabella? Brackets. Is there more than one number in the bottom? Isabella? Brackets. Although a 0 I might tend to ignore. But it's going to be bracket 10 take away 2 divided by bracket 0.8 minus 0. I probably didn't need to type the minus 0, so I'll just do that, which means I didn't need the brackets in the bottom after all. But you get an acceleration of 10, yes? 10 what? Part B says write an equation for the graph. Okay. Well, every single equation normally looks like this. Y equals mx plus b. Except, what will I use instead of y? V, I agree. M, 10. X, t. Plus, hey, what's the y-intercept? 2. Except, underneath, I'm going to write this algebraically. I think what we've really just derived is this. V equals, what was the slope? What did it mean? I know it's 10. What was the slope of a velocity time graph? Times t plus, what is that 2? Say the whole thing you said, the first thing. VI. You know what? I think we've just derived this. VF equals VI plus AT, our equation from last day. It's just, if we get it from a graph, we go mx plus b instead of b plus mx, but it really is y equals mx plus b in disguise. Kind of cool in a nerdy sort of a way. Sitting there the whole time. So, by the definition of constant acceleration, acceleration is the velocity change per second. Total velocity, you know what? Here's what we have. This is our first big equation. That's for speed. Hey, now it's velocity, velocity, and acceleration. I said last class, because several of you were away, I said, Marcus, last class, most of the time, we'll just assume positive is forwards and negative is backwards. I'm not going to do a big song and dance about all the north, south, east square bracket crap that they did in Science 10. Also, those of you from last lesson, remember, we actually derived the acceleration equation by saying acceleration was v final minus v initial over t. But I'm going to argue that's the same equation. I just rearranged it. Why do I like this one? Why do I like this version better? No fractions. You guys suck at fractions. For you, it's the math F word, not the F word you're thinking of. Okay. So v final, v initial, a, and t. How many different variables are there in this equation? 4. How many different ways are there to write this equation? 4. To find the displacement or distance if we're doing scalars, displacement if it's vectors, we can't use d equals vt because that's only true for a constant speed. That's not true if you're accelerating. We can use our definition of average velocity, though. It turns out I want to get the d by itself. What's on the same side as the d? A t. What's the t time? What's t doing to the d? Adding, subtracting, multiplying, or dividing? Dividing. So how would I move it over? Braden. I'm going to argue that I can say this. Displacement equals average velocity times time. Except, I want to talk about average. Braden, if you have 10 bucks and I have 20 bucks, what do we average? 15. If you have 20 bucks and I have 60 bucks, what do we average? How are you calculating that? The number in the middle. Can you be more specific? Give me an algorithm. Okay, you know what? I'll give you a tougher one. If you have $10 and I have $11, what do we average? 10.5. How can you take a 10 and an 11 and get 10.5 as an answer? How do you, whenever we say average, what are you actually doing? Yeah. Add them up and divide by 2 in this case, because it's, okay, you know what? Over here, let's write v av equals the initial plus the final divided by, not divided by t, divided by 2. Hayden, you okay with that? I think that's how you find the average of two things. You add them up, divide by 2. You okay with that? Well, what that means then is we can go like this. We can actually write this equation as d equals vi plus vf. The t drops down like a domino. And then you can either, look up for a second, you can either divide by 2, but I think on your formula sheet, I think I just tucked a 1/2 in the front. Can you find that on your purple formula sheet? Is that how I, yeah. See it? Second column over, third one down. That's this equation in disguise. By the way, you might notice there's 4 variables in there, which means that equation can be written 4 different ways. You okay with that? So this assumes uniform, turn the page, or unchanging acceleration. I think I went on my rant last class. I said if we have changing acceleration, you really need calculus. It gets a little ugly. So if we have uniform acceleration, we can find average speed. You know what? We've turned the page. I'll rewrite it because I'm going to reuse it. We said v average was equal to the initial plus the final divided by 2. Braden's law there. Actually, no, Nevada came up with that. We'll call it Nevada's law. Add them up and divide by 2. And we define distance as average speed times time. So we said this. Distance equals vi plus vf over 2 times time. I'm going to, Jaden, do some algebra here. I will not ask you to reproduce this on a test. This is Mr. Dewick, math nerd, saying, I like to show you where stuff comes from whenever possible. So we've taken this equation here. Again, I'm arguing Marcus, putting a 1/2 in the front is the same as, timesing by 1/2 is the same as dividing by 2. You okay with that, Isabella? And what's VF the same as? Our first equation, VI plus AT. Tyler, what I'm going to do then is I'm going to replace the VF right there with a VI plus AT. Is that okay so far? I'm doing substitution if you really want to be fussy. I get this. D equals, there's still going to be an over 2. There's still going to be an open bracket. There's still going to be a VI and a plus. What am I going to write instead of VF? What's VF the same as? What can I replace VF with? So I'm going to, instead of writing the VF, I'm going to say VI plus AT. Oh, and then this T drops down like a domino as well. Luke, same equation. Uglier, yeah. By the way, is my seating plan still making it around somewhere? Make sure it gets around, right? Uglier. Where is my seating plan at? Okay, has it got to everybody yet? Pass it to an empty desk. A desk that hasn't been filled. Look at the seating plan. Pass it somewhere in the direction that hasn't been filled out yet. There you go. Thank you, thank you, thank you. And if it has been completely filled out, just pass it back to me. All right, back here. Attention span. Back here. Hey. What's x plus x? 2x. No, not x squared. 2x. What's y plus y? 2y. What's vi plus vi? So we get this. 2vi plus at Ace, you okay with that? And then I'm going to get rid of brackets. So what I'm going to do is I'm going to multiply the t onto there and onto there. If you had Mr. Rocca, he calls it front door bomber. It's actually called distribute, but get rid of brackets. What's that going to give me? I got lots of room. Yeah, good. D equals, it's going to give me 2 VI t plus a. Hey, Rob, what's t times t?
No t squared. Oh, man, I'm so done today.
T, I thought I was giving you a chance to redeem yourself.
So sorry, Mr. Groot.
You're letting me down. Again, Hannah, let me emphasize, I will not ask you to reproduce this procedure on a test. What we're going to get is a brand new equation, and that's the one, in fact, probably the single most important, useful equation you get all year. We're not quite done yet. Is this divided by 2? Say yes. Is this also divided by 2? Say yes. What you can actually do then is you can write this as 2 VIT over 2 plus AT squared over 2. You can split it up. Thank you. Why did I do that? Hey, what's 2 divided by 2? They cancel. In fact, here's our new equation. This is the displacement equation that can handle acceleration. I wish we could have given it to you in in Science 10, because you can do so many more interesting questions now. It's going to be VIT, because you all told me that the 2's cancel, plus, and then look up for 1 second. What are we dividing this one by? Again, what are we dividing this one by? Dividing by 2 is the same as timesing by what? As a fraction, please. Plus a half AT squared. I guarantee that one's on your purple formula sheet. Find it. By the way, make sure you know where this equation is on your formula sheet. Train your eyes where to look. Make sure you know where this equation is on your formula sheet. Train your eyes where to look. And make sure you know where this where is this equation on your formula sheet? It's on there, yeah? Find it? You have to look. You can't just say, I don't know, because then you're going to flunk the test. Sorry, but I got to be that brutal. You're going to flunk the test because you're not going to know how to find it. Find it? Sure. Yeah, okay. By the way, also what I'm trying to teach you, and I kid you not, Natalie, I'm big on this. No, who did I have for science? To Cam, I had you last year. This is the same as the periodic table. You can actually train your eyes where to look, and you'll glance in the right place without realizing you're glancing in the right place. So part of what I'm trying to do here is see where the equation is so that when you're doing the homework or on a test, Hayden, and you think, I need the velocity equation, your eyes just know where to look without you thinking about it. So this is what we'll put in this box here. D vector equals VIT vector plus a half AT squared vector. Now, how do I type a 1/2 on my calculator? Oh, I'll decimalize it. How will I do that? 0.5. Or you can go 1 divided by 2, but 1 divided by 2 is 3 character strokes. 0.5 is 2 character strokes. Yes, I actually have counted that much, and I want to be as efficient as possible. So I've given you 3 equations so far. 1, 2, 3. Here's the 4th one. I'm not going to bother deriving it because it's going to pop up easily later on. The 4th equation is this. VF squared equals VI squared plus 2AD. VF squared equals VI squared plus 2AD. These are the big 4. Can you find that one on your purple formula sheet so you know where it is? It's there somewhere. In fact, I think almost all of them are in like one long single row, I think, except for the, oh yeah, they all are. What is it? Isabella, 3rd row down? Those are your big 4. In fact, those 4 cover everything above. They'll handle it just fine. So if you want to see where this one comes from, if you're a math nerd, I can show you later. It's cool. But here they are. These are the 4 uniform acceleration equations. Sometimes you'll see it written as V initial. Sometimes, because it's happening at time 0, you'll see it written as a 0. So the notes that I stole this from have zeros there. 0 is interchangeable with initial. In fact, I had a British physics teacher, my high school physics teacher, one of my nerd heroes. And so in Britain, it's called a naught. A 0, so he always talked about V0. You may hear me say that once in a while in my homage to Mr. Cowell, my good physics teacher. VF equals VI plus AT. D equals VF plus VI times T over 2, or you can times by 1/2. Those are interchangeable. Dividing by 2 is the same as timesing by 1/2. D equals VIT plus a half AT squared, and VF squared equals VI squared plus 2AD. Let's do some examples. I'm going to be, Luke, strongly encouraging you to use my DFIC approach. Now, in fact, what I've done for today is I've done the DFICing for you. I've listed the data for you. Next class, all we're going to be doing is applying this to actual questions. But first, I have to get you comfortable with the arithmetic and the algebra before we can plunge into the physics. So if you look at example 1, what are they asking you to find? And I would normally write down T equals question mark. Did I do that for you already? Here's the key. What I'm really saying is this. I'm looking for an equation. It has to have time in it, and it has to have VF, VI, and A. Which equation? There's 4 equations. The 4th one doesn't have time in it at all, so I would, in my mind, scratch that. Which equation is the one that I have to go to? Which equation has VI, VF, A, and T in it? Read it to me, please, Derek. Write that down. And believe it or not, I will give you 1 mark for being able to do that for this unit. Except, what am I trying to find, Isabella? What has a question mark next to it? I want to get the T by itself. I'll put a dot above it just so you can see the T. See the T? You don't have to, but this is just so it stands out. See the T? See the T? I want to rewrite this equation and get the T by itself. How? Well, what's the A doing to the T? Adding, subtracting, multiplying, or dividing? multiplying. How will I move the a over? Divide. Later. What's the VI doing? Adding. How do you know? Plus. How will I move the VI over? Subtract. You okay with that? So here's my new equation. This is not on your formula sheet. Please don't try and memorize it. This is how you can derive it. And this is what I want to teach you. I guess the VF would just drop down like a domino. Derek said I would minus the VI over. Now that would leave me with, don't write this next bit down, don't write this next bit down, just imagine it. That would leave me with that. That would drop down. But how did you say I'm going to move the A over? There's another equation, not on your formula sheet. You can memorize that one if you really feel like it. Knock yourself out. I would strongly encourage you. I'm going to teach you how you can derive these. In fact, Derek, I'm going to push you, I hope, to be able to do that all in your head, showing no work, like we just kind of did. Now we plug in numbers. What's V final? What's V initial? 3.2. If you get this far, it does become plug and chug, although there is some calculator work as well. How many seconds will it take you if you start at 3.2 meters per second and you accelerate to 29.6 meters per second at 2.9 meters per second squared? Please try typing this into your calculator. Is there a fraction? Yes. Is there more than one number on the top? Yes. Brackets around the top. Yeah, type this in. You already did? Okay. And this also, Taylor, is where graphing would no longer have, there was no way from a graph that I could have got an answer that accurate. Remember, we were kind of guessing half the time on our graphs. If they didn't go through a grid line, we were like, oh, it looks about 2.5, maybe 2.4, maybe. Here, bang on. How many sig figs should I go to in this question, technically? 2. So I'm going to go 9.1. 9.1 what? Seconds. If you want to reach 29.6 meters per second, it's going to take you 9.1 seconds if that's all you can accelerate at. Example 2. Cam, when you're done yawning, what are they asking me to find? Or displacement. I think technically displacement, but I'm not. You know what? As long as we're careful with our inputs, the values will take care of themselves and we'll get the right answer anyhow. Okay? You know what? D. That's what they're asking me to find. What else did they give me? VI, A, and T. I'm looking for an equation that has those in it. Or if you want to, you can say, what's missing? There's no VF, so I can't use an equation that has a VF in it. Which equation? I want you to read it, because there's actually in real life no numerical order. We don't say the third or the fourth. Which equation? Folks, which equation? And that's how we'll say it from now on. D equals VIT plus a half AT squared. Okay? You don't, in other words, you don't need to say displacement equals initial velocity times time plus a half of the accelerator. Just read it out with variables. That also, in my mind, reinforces in your brain which variables go with which concepts. What are we trying to find, Cam? We would want to get the D bytes. Oh! Hey, it already is. Plug and chug. Cam, what's VI? I guess we started out going backwards. Okay. What's time? 12 seconds plus, and I'll type 0.5 because that's what I'm going to write on my calculator. What's A? By the way, are we speeding up or slowing down? Well, we started out going backwards. We're accelerating forwards. I guess we're going to slow down for, but I bet you we're actually going to end up, because we're going for 12 whole seconds, I think we're going to end up going in a positive displacement. Good, plug and chug. Now, you need to make sure you know where your squared button is. You all have one if you've gotten a good calculator. Negative 1.5 times 12 plus 0.5 times 4.5 times 12 squared. And you should be able to just type it in like that. I'm pretty sure you're going to get a positive answer here. You get 306 meters. Nice. Again, trying to do this with graphs, Ty, would be a nightmare. 306 what? Units? Meters, and I tend to put a box around my final answer, like, yay. Let's kick it up a notch. Let's kick it up a notch. Ty, what are they asking me to find in number 3? VI. So already I'm looking for an equation that has to have a VI in it. I mean, that may seem really obvious, but knock, knock, hello, okay? They also, it looks like they gave me A and D and T. Which is my starting point? Which equation can I use to solve this? Ty, which one? Yeah, sure.
Maybe like the second one.
Read it to me, please.
D equals 1 over 2 bracket VI
Yep.
plus VF.
Stop. Plus what? VF, you said? Have they given me VF?
No.
So I have to say I don't think that equation's going to do it. Let's try another one. And by the way, I'm glad you did. This is the process of elimination that you'll start to do mentally. So you looked at that one, read it to yourself without writing anything down, check to see if they gave, oh, missing VF. Let's try the next one. Kareem.
D is equal to VI.
A half AT squared. In fact, the same one as the previous in this case. Okay. Ty, back to you. What did you say they're asking us to find?
VI.
That's this puppy right here. I'll put a little dot just so you can track it. You don't have to, but that there. That's what I want to get by itself. What's right next to the VI? T, what's the T doing? I think I'm going to divide by T, but later, later. I need to move this thing over. That half AT squared. What's that half AT squared doing to the VI? Adding. So how will I move it over? So if I hear you correctly, and I think I do, you're telling me the D would drop down. I would subtract a 0.5 AT squared. I changed the 1/2 to a 0.5 because I'm going to go with my calculator anyways. What that would leave me with is, don't write this next bit down. That would leave me with the VIT just dropping down. But Mason, what did you tell me the T is doing to the VI? So how did you say I'm going to move the T over? So I'm going to go the whole thing by T. There's yet another equation. Again, Nat, you can memorize that one if you want. Please don't. By the way, this is intimidating. I know it will take a couple of days, but I guarantee if you don't quit on me, I can get you getting the hang of this formula manipulation. And Derek, it's a great way to do this. It so cuts down on your memorization. Because now, it's plug and chug. Tyler, coming back to you. What's D?
Sorry, what?
Coming back to you. I'm going to now fill in the variables. What's D in this question?
40 minus 40.
Negative. I guess we started behind the start line? Okay. Negative 40. Take away 0.5. Ty, keep going. What's A?
Negative 3.5.
We're accelerating backwards. Okay. What's T?
24 seconds.
So 24 and then squared, right? Because it is T squared in the equation. All divided by, what's T again?
24.
I really want you to practice. See if you can type that one into your calculator. You should be able to get it in one step, not in chunks. in one step. Is there fraction? Yeah. Is there more than one thing on the top? So I'm going to put the whole top in brackets. Then it varies from calculator to calculator. This is why, Cam, I get so annoyed when you don't have your own, because your calculator, your own, might work different from that one. But that's okay. I'd rather have you following along. So bracket, negative 40. Make sure you use a negative and not a subtraction sign. Take away, now I'll use a subtraction sign. 0.5 times negative 3.5 times 24 squared. Again, you'll notice I don't use brackets for times. I use times for times. Close off the top, divided by 24. Try typing that in. James, you alive? Give him an elbow for me. Wake up, James. You get 40.3333333. No? Yes? Okay, most of you are nodding. Again, if you're not, I will help you with your calculator. Yeah. Quick look at money. How many sig figs should I go to here? Technically 2. I'm going to go to 3. I'm going to go 40.3. Negative. No, positive. Sorry. 40.3. What? What did we just find? Meters per second, because we just found a velocity. Coming back to Ty again. Ty, it looks like we started out going forwards. We accelerated backwards. We ended up behind the start line. That's how fast we must have been going forwards for that to occur at the beginning. A few more, we're done. Example 4. Example 4. Jaden, what's this question asking me to find? Yeah, VF. So I'm already looking for an equation. It has to have VF, which, by the way, means I'm not using, whoop, didn't want to do that. It means I'm not using this equation because this equation doesn't have VF in it. I've already scratched one off my list. Looks like they also gave me VI, A, and D. What didn't they give me? What's missing from that list? Okay, I can't use an equation with time in it. Can you see which equation, Jaden? Yes. Say it loud and proud. What was that? You okay with that? What did you say we're trying to find? Have I got the VF by itself in my equation? Not quite. I have the VF squared by itself. So here's my question. What's the opposite of squaring? Derek. So now that we've written this down, if all of you want to put a little slash through there, and then a great big square root over here. Now we've got the VF by itself. I know it looks complicated. Let's plug and chug. Great big square root. Jaden, what's VI? And then my equation is 12.5 squared. Yes? Plus 2. What's A, Jaden? Positive or negative? 9? 9.8 positive. And D is 126. Okay. Can I give you some advice with square roots, in particular for this equation here? Here's what I recommend. Type what's inside the square root first. In other words, I'm going to go like this. 12.5 squared plus 2 times 9.8 times 126 equals, and then I go square root answer button. Trust me, that works better. I do that. Do you know how to find your answer button? It's the shift negative on your calculator. Square root is shift x squared. So now I'm going to pause. You need to find your square root button, and you need to find your answer button, and you need to see if on your calculator you can get 51.2. I'll pause for a second. What do we get? 51.2. Probably should go to 2 sig figs because of the, I'll go 51.2. 51.2 what? It's a velocity we just found. If I was clever, I would have told you it's worth memorizing what units go with what. Again, Luke, what are we really saying? If you start out going 12.5 meters per second, and you accelerate at 9.8 meters per second squared, and you're only allowed to travel 126 meters, at the end of that, you're going to be going 51.2 meters per second. 2 more, we're done. Example 5. Example 5. Whew. Marcus, what are they asking me to find in example 5, my friend? Okay. By the way, if you glance at example 5, what didn't I give you? In other words, when you're picking your equation, don't say one with t in it. Which equation has a VF, a VI, and a D in it? Marcus, my friend. VF squared equals? Nice. By the way, I'm spending so much time on this. If you can't find the equation, you're stuck. I can't help you. So I'm trying to show you this is how we use a process of elimination to pick the correct equation. Then we say, Marcus, what are they asking me to find? That guy there. See it, see it, see it, see it? What are the 2 and the D doing to the A? Adding, subtracting, multiplying, or dividing? You know what? I think I'm going to divide by 2D later on. I'm going to divide by 2D. Did I start my... Good. Making sure I kept going. But there's also this thing here. This, what's this VI squared doing? Adding, subtracting, multiplying? Sorry? Okay. So I'm going to move this over by minusing. The VF squared is going to drop down like a domino. There's going to be a minus VI squared. Is that okay, Isabella? So far, so good? And then don't write this next bit down. I want you to just see it in your head, but I'll write it. The 2AD would drop down. But what did you tell me we're trying to get by itself? So I need to get rid of the 2 and the D. What are they doing? So you're saying I would? Yet another equation. Don't memorize it. Now you can write that down. In fact, now we're in the plug and chug range. VF 12 squared minus VI 20 squared all over 2 times 86. Is there a fraction, Hannah? Yes. Is there more than one number on the top? Brackets. Oh, is there more than one number on the bottom? Brackets. If I'm going to type this in, it's going to look like this. Bracket 12 squared minus 20 squared. Close the bracket off. Divided by bracket 2 times 8.6. Oh, no, not 8.6. I can't even read my own writing. 86. And I get negative. Oh, wait a minute. What was my initial velocity, Marcus? What was my final velocity? Am I speeding up or slowing down? Why? Yeah, you know what? I should have expected a negative acceleration. That makes me now think I did it right. Because I used to be going 20, now I'm going 12. I slowed down. Negative. Is that right? Negative 1.48, blah, 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 blah. I'll go negative 1.49, I guess. Really, I should go negative 1.5. But it's negative. Units, it's acceleration. Are you cluing in why I told you it was worth memorizing what units go with? It's your final little touchdown spike at the end. If you want it, you can put a box around there like, yeah, I got the right answer. Last one! And then you swore. That's not good. Luke, my friend, look at example 6. What are they asking you to find? Okay, I'm looking for an equation that has VI, A, T, and D in it.
D equals VIT plus.
Yes, keep going.
D equals VIT plus half AT squared.
It is that. This one is nice for another reason. Actually, normally you can't solve for time with this equation with your math skills. Have you guys in Math 11 done the quadratic formula yet? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a? Okay, so this is called a quadratic equation. Normally you can't solve it, but I picked my numbers carefully. Are any of these zeros? Which one? So all of us, let's put a little equals 0 right there. So Luke, what's 0 times t? Because what's 0 times anything? So because of this, I get a new special sub-equation. I can actually say this is going to cancel, and what I really have is that. Wait a minute, Mr. Duke, where'd the over 2 come from? What's timesing a half the same as dividing by? And this looks prettier. What did you say we're trying to find? Let's get the t by itself. See the a? What's the a doing to the t? How will I move it over then? What's the 2 doing to the t? This 2. How will I move it over? So the first thing I would say is this. The d stays where it is. Luke, you're telling me the 2 is going to times. The a is going to divide. And that's going to give me, what did you say we're trying to get by itself? I haven't quite got it by itself. I got a t squared by itself. Oh, how do I get rid of a squared? This is formula manipulation with a vengeance. This is what we're doing. So, if I hear you correctly, Luke, and I think I do, you're telling me that t is going to be a square root of 2 times the distance divided by the acceleration. You know what? Is there a square root here, Luke? Yeah. I'm going to type what's inside the square root, hit equals, and then I'm going to go square root answer button. I get 15.5 seconds. .5 seconds. I've thrown an awful lot at you. This is fundamental to everything we're going to be doing for the remainder of the month. Which is why I was grumpy at some of you that weren't trying this on your calculator. You're going to find it's much more difficult than it looks. What's your homework? So I've given you a whole bunch of questions here. Please, did I give you the answers, Mr. Duick? Oh, I scrambled the answers. That was mean of me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Well, there's 19 answers and 19 questions. What was that? Question? Yeah, it's 19. You need to practice this. I'm sorry. I haven't found a way. By the way, if we hadn't done the shuffle, you'd have 25 minutes to do 19 questions, but the shuffle took 15. So, sorry. What we're working towards, by the way, you guys have school a week from today? It's a Pro D day, so we're going to try and aim for less or no homework for that weekend, which means I'm going to push you today and Wednesday. Okay?